I'm reviewing all of Unit 3, all of the functions that we've transformed. So quadratic, we're going to start with, looks like y equals x squared, has a 2 up in the corner. Looks like a U shape with a locator right there. It could be a U shape or face down and be like an N shape. The pattern that we follow for a quadratic is we go left and right by 1 and up by 1, left and right by 2 and up by 4, and so on. And we get these numbers from squaring each of them. So 3 squared is 9, 2 squared is 4, 1 squared is 1. Absolute, so that's the quadratic function. U-shaped has a squared in the equation. An absolute value function has these lines around it. That's the symbol for absolute value. It's a V shape with a locator right there at the bottom. And our steps we take and our pattern we follow is to go left and right by 1, but up by 1. Left and right by 2 and up by 2, left and right by 3 and up by 3, and that comes from taking the absolute value and always getting a positive number. So it always turns it positive. So we'll always go up. Like that. That's an absolute value. It's a V shape. Square root goes like this. It has a starting point and it just shoots out to the side. It has a square root symbol in the equation. We have a locator starting point there. And the pattern we follow is we go right 1 up 1, right 4 up 2. And that's because when we take the square root of 4, we get 2. When we take the square root of 9, we get 3. So the square root symbol, that's the square root graph. Cubic has a 3 as the exponent, x cubed. It's kind of an S shape, has the locator right there at the origin. The pattern we follow here is we go right by 1 and up by 1, left by 1, but down by 1. Because when we cube 1, we get positive 1. But if we cube negative 1, we get negative 1. So negative 1 times negative 1 times negative 1 is a negative 1. And that's why we go down, because it's negative. So when we go left, we go down. When we go left by 2, we would go down by 8. And likewise. So this is the cubic function, has a cube in the symbol, a 3 in the symbol, and the exponent. Now this is our general form. Important to notice here is that the h and the k together make up the locator for all of these graphs. And you can see that in red for each of these. This is the locator, this is, and this is. They all have a locator that comes from hk. I'm just going to write this on the side. HK is always the locator for all of these graphs. That's the locator. Now H and K also have to do with shifting. That's how we're going to move it. So H is going to shift it left and right is the horizontal shift. K moves it up and down. That's the vertical shift. And the A is either going to flip it or it's going to give it a vertical stretch. It'll make it 2 times as stretchy or 2 times as steep. Maybe it'll be half as steep. Depends on the number that's there. So let's take a look at an example here. So here I have y equals negative 2 times the square root of x plus 1. This is our parent graph here. I just copied it from my table before. And I'm going to transform this parent graph by just starting out by labeling the transformations here. I see I have a negative 2 and a 1, and again, this is a square root function. So the transformations that I notice here, first one I'm noticing is that I have the plus 1 inside of the square root symbol. So that's going to be to go to the left by 1, and the reason we're going left or backwards is because the x always lies. So we're going to go back by 1, left by 1, and then it's going to be stretched by 2, that's the 2 out front, and it's going to flip because it has a negative sign. So I have 3 different transformations going on here. I'm going to first start by shifting it to the left by 1. So here is my new locator. This is my new locator. Because I took the old one, I shifted it to the left by 1, and now I'm going to transform it. So the pattern, the original pattern for a square root function is to go right by 1, up by 1, right by 4, and up by 2. But I'm transforming this by stretching it and flipping it. Okay, so if I'm going to stretch it by 2, first I'm going to look at those vertical movements. So instead of going up by 1, I'm going up by 2. Instead of going up by 2, I'm going up by 4. It's twice as steep. I'm just doubling those values. So I'm going to go right by 1, but up by, actually I'm going to go down by 2 because it's flipped. So not only am I stretching it by 2, but I'm also going down. So when I go right by 4, instead of going up by 2, I'm going to go down by 4 because I doubled it. So I'm doubling it and I'm going down. I'm doubling it and I'm going down. And this is the new pattern of the transformed square root. So I'm going to go right by 1 and down by 2, just like my new pattern is. And I'm going to go right by 4 and down by 4. And make a point right there. And now I'm going to connect my points. All right, so I've connected my points. I transformed our square root function by going to the right by 1, left by 1, stretching it by 2, and then flipping it. And that was the new pattern, and I went left by 1. All right.